I don't know.
Yes, how much you're getting, Shahid?
No, I'm not getting.
Okay, let me discuss then. Wait, let me discuss it with you. A parallel plate capacitor having square plate of side A. So parallel plate capacitor is there. This is a square, side is A. This is filled with dielectric constant K. Separation between the plates is D. You have to find equivalent capacitance if X is measured along the length of capacitance. See, how do we solve? I have told you, in the last class, whenever you have capacitor related questions in variable form, what you have to do, you have to consider a very small section. And how will you get it? Suppose we are taking a very narrow section. Let's say the thickness is dx. This narrow section, this thickness is dx. So area will become a dx. Remember, I hope you will recall the steps now. Last time also, last Wednesday also, we discussed one type of question. Now what will be dc? Capacitance will be equal to epsilon k epsilon naught dA over d. And now we'll put the value of dA. See, when we put the value of dA, what our C equivalent will be? Whenever it says, no, it is kept along the length. Whenever this is said, if X is measured along the length of plates, it means this connection is in series. This is along the length of plate. Like this. This is the length of plate. So it means this connection is series. One more thing, Shahid. If it says, no, along the separation between the plates, that is this separation, then we say this is parallel combination. So right now, since this is series combination, our C equivalent will be equal to C1 plus C2, like this. Now, since we are considering very small capacitances, this is DC1 plus DC2. Now, in any ways, we are considering C equivalent. What is our C equivalent equal to? We are integrating DC. Or leave this step. No, I have to write this step. K epsilon naught dA over the separation, small d. Fine. Now see, what we do, let's put the value of area first. Let's put the value DC is equal to K epsilon naught A dx over small d. Now to find the total equivalent capacitance, what we'll do, we'll integrate it. What all things are constant over here? And from where do we have to integrate? From 0, it's saying to the along the length. It means from 0 to the length, that is entire A. So from 0 to A, this is from 0 to C. Now K epsilon naught, this can be taken out. K epsilon naught A by D. A by D also can be taken common, or let's not take K common. Let's put K back because K is variable. K is not a constant right now. K is K1 plus K2x. See, K is equal to K1 plus K2x. So K is this time, it's not a constant for us. That's why we'll not integrate it out. So we'll just integrate this term. K dx from 0 to A, this is C. Now let's put the values of K epsilon naught A by D. Let's put the values. This is K1 plus K2x dx from 0 to A. All right, we have just substituted the value of K. Now what you can do, we can separate this. This is K1 dx. If you separate this epsilon naught A by D, integral K1 dx plus K2x dx from 0 to A. This is also integral from 0 to A. Now see what your equivalent capacitance will be. K1 is a constant, so this will be just as it is, epsilon naught A by D plus this becomes x square, right? X square by 2, K2 from 0 to A. So this becomes C becomes equal to K1 epsilon naught A by D plus K2 A square by 2. This is your final answer. Is it clear now, Shahid?
Yes, ma'am.
Okay, very good. Note down the solution, then we'll start with current electricity. Shahid, done?
Yes, ma'am.
Can we start with current electricity?
Yes, ma'am.
Okay. See, current electricity, most of the portions we have discussed in the class, so that theory part I'll not discuss, but I'll just mention. See, we know the basics of electric current. What is electric current? Rate of flow of charges. Whenever you have duration, you calculate average current. And whenever you have a particular time instant, you differentiate this. Last question was clear to you, no, Shahid, that capacitance one?
Yes, ma'am.
So please solve this question and one more question which we did. Remember that integration one?
Yeah, ma'am.
Okay. Practice those two, because in your JEE exam, no, these are the questions that make your exam difficult from other subjects, which you have to do in a limited period of time. Okay, so this is instantaneous current. So current is a scalar quantity, you know, its SI unit is ampere. Amperes, you know. Then one more thing regarding the currents formula, that is, it is charge per unit time. So we can write this as Q by 2 pi R into V, when we write time period as distance upon speed. Also current, this is written as charge multiplied by frequency. Here this is frequency. If ever needed, use these formula. This is velocity. But this is valid only in circle. Fine. Then we classify materials into 3 categories. Classification also. When we talk about classification, you have 3 materials to remember. First one is a conductor. What is a conductor? Conductor is a material that allows electrons to move. Fine. So in some materials, outer electrons of each atom or molecules are only weakly bound to it. So these electrons are almost free to move throughout the body of the material. And these are called as free electrons, which actually move out of the body. So, and we not only call them free electrons, we call them conduction electrons only. So when such a material is placed in an electric field, free electrons move in the opposite direction to field. And these materials which allow this to happen, we call them as conductors. Just opposite to it, dielectrics, or we have a common name, insulator. We use insulator term. So electrons are tightly bounded here. That's why the electrons aren't able to move and conduction doesn't occur. So we call them as insulator. Now, the materials having property in between conductor and insulator, we call them as semiconductor. Do not worry about semiconductors, because this you in any ways have to do it in detail. It's an easy lesson only, semiconductors, that we'll do towards the end. Fine. So these were the things that I wanted to discuss with you. One question I'll start with. One question, not just from these formula. Do one thing. Note down these points first, then I'll note down that question. Shahid, have you written the question?
Yes, ma'am.
Did you give it a try?
Now I'm trying.
Do you need 1 or 2 minutes or should I discuss?
Like what formula to use?
See, here it's best if you use current density. Should I discuss it? I think I should discuss, no?
Yeah.
Let me discuss it with you. See, it says a potential difference applied to the ends of the wire made up of alloy drives a current through it. The current density varies as J is equal to 3 plus 2R, where small r, this is the distance of the point from the axis. If capital R is the radius of the wire, now when you have curled it in the form of a circle, that radius is capital R. Now you have to find the total current through any cross section of it. Whenever current is involved and you see current is divided through area, always use this formula. Remember, we have done current density is equal to current per unit area. J is equal to current per unit area. In such cases, what we do, we have to find out current. So we take current, or let's take a small section, di is equal to J dot dA. This is how we find out, because we require it through surface area. You know what's the question is looking like? Let me show you a figure. This is the disk given to you. Now we have considered a very fine small disk whose radiuses are, this entire actual radius is capital R. And this is dr, this fine radius which we have taken, this very small one which we have taken is dr. All right, now see, you have this formula. We know what all things are given. Current density, I think, is mentioned in the question. Yes, it is already written current density. You know, it's cross section of the area means area is also involved. So this formula should automatically come into your mind. All that area is also involved, current density is involved, current is asked. So it's like this is unknown, these two are given, but the question is not very simple. We have to perform certain calculations. So to find out, we'll obviously integrate it from 0 to capital R, we have to integrate. So this from 0 to I. So I will be equal to, value of J is given in the question. 3 plus 2R. 3 plus 2R. This is the value of J from 0 to capital R. And what about the area? Thickness. Thickness is dr. This thickness that I have told you, we are considering. This thickness is dr. The area will be 2 pi r. Right? Sorry, the circumference will be 2 pi r. So 2 pi r multiplied by the thickness, that will give you its area. This is how the length into breadth we take. In a circle, how will you get length into breadth? It will be 2 pi r multiplied by dr. So instead of area, we'll write 2 pi r dr. That's it. This you have to solve, integrate. Now look, this becomes, let's do one thing, 2 pi r is there, 2 pi r dr is there. So if we integrate, this becomes 3. 3 is a constant number itself. We just have to integrate it now. So what we'll do, we'll integrate it separately. So 2 pi, you can take this as common. So this becomes, if you take 2 pi from here, r dr is left. That becomes r square by 2. See, from here, if we are integrating this, this becomes r square by 2. So this 2, this 2, this will get cancelled. Right? And how much will dr will be left? And from here, you already had 3 plus 2r. So if we take, what we can take common? 2 pi we can take common. 2 pi you can take it outside. If you take 2 pi outside, that becomes, or let's do one thing instead of this step. No, Wait. Otherwise, that will be a lengthy process and we will have to put a constant term. What we can do, let's take it directly from here. If you multiply this becomes 2 pi r into 3 plus this becomes 2 pi r into 2r, right? And this entire term dr integral from 0 to r. In one line now you will get your answer. Otherwise, a constant term could have been. Let's take 2 pi common from here. What is left from here? 3r plus what is left? 2r square dr. Now this is clear, Shahid? This is better, no?
Yes, ma'am.
Okay. So now you will be able to solve this. This is integration from 0 to r. You have to get this will become 2 pi 3. This becomes r square by 2 from 0 to r plus 2r cube by 3 from 0 to r. Integral from limits we have to just substitute. So this becomes 2 pi 3r square by 2 plus this becomes 2r cube by 3. So this is your final answer. This much of units is your final answer. Note it down. This is clear, Shahid?
Yes, ma'am. Ma'am, in the second step, we have taken A as 2 pi r. We should take pi r square.
2 pi r into dr. We are not taking the volume. See, if we consider the volume, then we take the entire area multiplied to thickness. Then we would have taken pi r square dr. We are considering area. So area, how do you write? If it's a square or a rectangle, length into breadth. So in circle, we take length into breadth. What is the length of a circle? 2 pi r. What is the breadth, the thickness, dr? Had it
Yeah.
been volume, let's say it is dv, then what you would do? Area into volume. So area would have been pi r square, then into dr. Clear?
Yeah.
Done?
No, I'm right. Done, ma'am.
Okay, okay. Sure. Just a few points, then one more question from the theory part, then we are just left with the circuits. See, regarding the theory portion, you should know that under 1 ampere, you have 6.25 into 10 to the power 18 electrons per seconds moving. Why? Because this question can come and you will waste your time in your calculation. So you directly learn this value, I would suggest. And one thing that can be confusing, always remember that current is a scalar quantity. As we have discussed, that though it has a magnitude, it has its direction, but it still doesn't obey the vector law. So we do not consider it as a vector quantity. But what you have to be careful while answering this question is current density. Current density is a vector quantity. You apply all the laws of parallelogram law over here. Okay. And one thing, when you have to find out the order of the free electrons, there are so many free electrons in a conductor, right? So what will be the order of free electrons? This also you should remember. Order of free electrons in a conductor is 10 to the power 8 meter per second. Electrons per meter cube. In 1 meter cube, these much electrons are present. Then the next thing that I have already discussed in the class, that is current through two cross sections will remain constant, even though one area is bigger, other area is small. What will happen to current density? Current density will be greater in the opposite area, because we know current density is inversely proportional to area. That's why if A2 is greater, so J2 will be lesser. And same thing occurs for electric field also. E1 would be greater than E2. And exactly same thing will occur in drift velocity also. Vd1 is equal to Vt2. These are the basic points which you should remember. Quickly note down this page, then we'll practice one question, which I was mentioning. See, a current of 1.34 ampere exists in a copper wire of cross section 1 millimeter square. Assuming each copper atom contributes one free electron, calculate the drift speed of free electron in the wire. The density of copper is 8,990 kg per meter cube and atomic mass is 63.50. Here you have to apply a little bit concept of your chemistry, which you have done. Lesson 1, mole concepts, which you must have completed in class 11. That concept you have to apply. Firstly, mass of 1 meter cube, how much it is containing? Mass of 1 meter cube volume of copper. It's given to you in the question. 8990. See, this atomic mass unit, do you know what its SI unit? Or do you know in which unit do we write the atomic mass?
Gram.
Grams, right. That's why we have to convert this kg per meter cube. No, this kg also into gram. So we'll write this 10 to the power 3 grams. That's why. Otherwise, this was fine. Now, number of moles. If you know mass, number of moles are written. No, mass divided by molar mass, the gram molar mass. So number of moles will be masses 8990 into 10 to the power 3. Molar mass is 63.5. This should be around, if this is 9,090, 63.5. So this will be, let me check first. This should be around 1.4 into 10 to the power 5. Okay, please just cross check this once while you're writing. So this is the number of moles you're having. Now see, since each mole is having how many atoms? What is Avogadro's number?
6.022.
How much?
6.022 into 10 to the power 20.
6022.
Yeah. 6.022 into 10 to the power
6022 into 10 to the power
23.
This is what you're saying?
Yes. 6.0.
6.0. Yes, 6. So let's take this as 6 into 10 to the power 23. This is Avogadro's number, right? So each mole contains, this is how much is contained by each mole. So each mole contains this much of number, right? This much of number is contained by it. So in 1 meter cube, how much it will contain, right? This is what we have calculated. So we'll just multiply it. So number final becomes number of atoms in 1 meter cube. Number of atoms 6 into 10 to the power 23 into 1.4 into 10 to the power 5. So once you'll solve this, this should be around 8.4 into 10 to the power 28. Now see, we have to find out current. Now we don't know the number of atoms. So I is equal to NEA VD. NE VD into A. What do we have to find? Unknown is drift velocity. So drift velocity will be current divided by NEA. So drift velocity will be equal to current is 1. How much is the current given? 1.34. Yes, current is 1.34. Number of atoms we have calculated 8.4 into 10 to the power 28. Electronic charge 1.6 into 10 to the power minus 19. And area is given 1 millimeter cube. So it becomes into 10 to the power minus 6. Whatever this should come, that would be your final answer. This much meter per second. Clear?
Yes, ma'am.
Okay, quickly note down the solution and keep on updating me. I'll scroll accordingly. So we'll just practice circuits in the next class. We are left with circuits. This is the theory part, all the theory part that we did know in the class before the resistors and the circuit. So this is it.
I'm done. Done. Done, ma'am.
Completed, Shahid?
Yes, ma'am.
Okay, Shahid. So the